Okay, this video is about multiplying fractions, and it's meant to be a review. And before we get into multiplying fractions, well, there's a lot to explain, but let's make sure we understand how we think of multiplication of integers. So if I have something like 2 times 3, there are lots of ways to represent it, but the way I'll represent it is you take 3, so here's the number line, 2, 3. So you start with 3, you take a segment of length 3, and then you add another segment of length 3 to the right of it. And I'm only going to be talking about positive numbers here. So you take a line segment of length 3, and then you take another line segment of length 3. 1, 2, 3. Where are you on the number line? You're at 6. So 2 times 3 is 6. Now we're going to make sense of something like 1/2 times 4. Well, here, so here's the number line, 0, 1, 2, 3, 4. I start off with length 4. Now I'm going to define 1/2. Well, 1/2 times 4 is defined to be what I get when I take 4 and divide by 2 means the length of a piece of 4 units when divided into 2 units of equal length. And if you take 4, this piece of length 4, and split it into 2 equal pieces, it'll be here. And this length is 2. Right? And you have a length of 2 here. And 2 plus 2 is 4. 1/2 times 4 by definition is 2. And another example is, let's look at 1/2 times 10. Well, again, what this means is I have a number line 0 to 10. And okay, I could draw the tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I have this line segment of length 10, and I divide it into 2 pieces of equal length. How long is each piece? Well, each piece will have length 5. Because if I split it into a segment of length 5 and have another segment of length 5 and add them together, I get 10. So in other words, 1/2 times an integer, let's call it d, means d divided by 2. That's the first critical thing to understand. It's very important to understand this before moving on. Okay, now let's multiply 1/2 by, and in general, 1 over n times d means I take d and divide by n. So for instance, if I had 1/3 times 6, this is the same as 6 divided by 3, and that's 2. Okay, maybe one more example. 1/7 times 42 is 42 divided by 7 makes 6. So the answer is 6. 1/7 times 42 is 6. Now let's talk about taking something like 1/2 times a fraction. So let's say that you had 4/5. Now we need to say what this means. And again, what this means is you take 4/5, you divide it into 2 equal pieces. How long is each piece? So here's my number line. 0, 1, 2, and I split it into 5 equal pieces to have fifths. So this is 1/5, that's 2/5, 3/5, 4/5. So here's 4/5. And remember, when you're thinking of 4/5, you want to think of 4/5 as 1/5 plus 1/5 plus 1/5 plus 1/5. I have 4 1/5 that I'm adding together. And so if I divide this segment into 2 pieces of equal length, each piece is going to be 1/5 plus 1/5. Like this. It's one piece of equal length and another piece of equal length. And that's 2/5 plus 2/5. So 1/2 times 4/5 equals 2/5. Okay. And let's do another example. Let's say I had 1/3 times 18/7. What would this be? Well, by definition, this is what I get when I take 18/7 and divide it equally into 3 pieces. So here's 0. 18/7 is a bit over 2. So here's 18/7. And now I want to split it into 3 equal pieces. And I ask myself, how long is each piece? Well, I need to get from 0/7, I have 0/7 here, and I need to get to 18/7 in 3, if you think of this as 3 jumps. Right? I need to get from 0/7 to 18/7 in 3 jumps. And I can do that by taking 18, I have 18/7, and I'm taking 18 of 1/7 and then dividing that by 3. Well, what's 18 divided by 3? 6. So I have 6 1/7. That's 6/7. And you can see that if I have 6/7 and then add 6/7 more, I get 12/7, and if I add 6/7 again, I get 18/7. So this is 6/7. 1/3 times 18/7 is 6/7. Okay. And then, yeah. Okay. I'm not even going to say what to do in general. Okay, let's go on to something where, see here, in these past examples, it was easy because the numerator here divided evenly into the denominator here. Right? 2 went into 4 evenly, and 3 went into 18 6 times evenly. But what if the numbers don't divide evenly. So, as in you're left with a remainder. Okay. So let's say I had something like 1/2 times 3/4. So again, here's my number line. Here's 0, here's 1. I split it into 4 equal pieces. And I have this length 3/4. And I'm asking myself, what number do I get when I take this length and split it into 2 equal pieces? Well, right now I have 3 1/4. And I can't split 3 into 2 evenly. But there is something we can do, because remember, we can always represent a fraction in multiple different ways. So for instance, if I have 3 1/4, right, how else can I represent this? This is 6 of what? This is 6 1/8, right? Because I can take my 3 1/4, so here's 1/4, here's another fourth, here's a third fourth, and I can split them into 2 pieces like this. And when you do that, you're going to have 6. 1, 2, 3, 4, 5, 6 pieces. And how long is each piece? Well, see, if you take the interval from 0 to 1 and just keep going, you see that I have 8 pieces of equal length. Right, so 3/4 is the same as 6 1/8. 3/4 is equal to 6/8. This is something that we've gone over, so hopefully you understand. But now, the good thing about this, right, why do we want to write this as 1/2 times 6/8? Because 6 gets divided by 2 evenly. If I have 1/2 times 6/8, what do I get? I get 3/8. Because I'm taking 6 1/8 and splitting it into 2 pieces, and so each piece will have length 3/8. And so we've just discovered that 1/2 times 3/4 is the same as 3/8. Okay, so the answer is 3/8. Let's do another example. Let's say I had 1/3 times 15 over 4. Well, actually, this is easy because 15 is divided by 3 evenly. It's 5/4, right? Okay, that was just a review. How about 1/3 times 8/5? Well, 8 does not divide into 3 pieces evenly, but how can I rewrite 8/5 so that I get a multiple of 3 on the top? Well, actually, I can just, so here's 0, here's 8, here's 1, so I divide into fifths, so fifths, and then 1 is 5/5, so 6/5, 7/5. So I have 8/5. And what can I do to get, I have 8 things, I have 8 1/5. how can I get something that's a multiple of 3? Well, I can divide each of these pieces into 3 pieces of equal length. So I can split it like this. Okay, so make it thinner. And now I have how many pieces? I have 15. I have 24 because I had 8 1/5. Each of those 8 pieces gets split into 3. So I have 24. 24 what? How long is each of these shorter pieces? It's 1/15. Because each of these was 1/5. And when I divide it into 3 equal pieces, right? Originally you need 5 1/5 to make 1, but since you divided each piece into 3 equal pieces, you need 3 times as many of these short segments to produce 1. And so each piece is 1/15. So each of these is 1/15. And one way to see it is that another way to see it is that 1/5 is the same as 3/15. So if you split it into 3 pieces, you get 1/15. Okay. So 8/5 is 24/15. So now this is 1/3 times 24/15, and this is equal to 9/15. Okay. And we're not going to worry about simplifying. You could reduce this to lowest terms, but we're just talking about how to multiply these fractions. Okay, so that's what you do whenever you have a case where this numerator does not divide evenly by that number. Okay. And in general, what you have is, let's say our original number is a over b, and you want to multiply on the left by 1 over n. So what's 1 over n times a over b? And a and b and n are all positive integers. Well, we can represent a over b as a times n over b times n. And this would be like if you took the length 1 over b and then split that into n equal pieces. Then you have 1 over b times n. And then if you have a of those 1 over b, then how many 1 over bn pieces do you have? You have a times n. Right. So here we're using this fact that hopefully you have learned, that you can represent any fraction in multiple ways just by multiplying the top and bottom by the same positive integer. And so, the good thing about this is that now you have a number, a times n, which does divide by n evenly. And if you take a times n of something and divide that into n pieces of equal length, how long is each piece? It's a. So it's a b times nth. That summarizes what we've done, right? You use this fact that you can represent a fraction a over b in multiple ways to write the fraction as a times n over b times n, and that way you can divide the number of pieces you have by n. Okay. So now the last thing we want to talk about is what happens when the numerator of the number we're multiplying is not 1. So in all these examples, I was working with 1 over something. So let's say that you had 2/3, a bit nicer, 2/3 times 6/7. Well, what this means is to multiply by 2/3 means first divide by 3 and then multiply by 2. That's what multiplying by 2 over 3 means, okay? So 1/3 times 6/7 would be what you get when you take 6/7 and divide that by 3. 2/3 times 6/7 means what you get when you take 6/7, divide by 3, and then multiply that by 2. Okay. So this means first we need to divide 6/7 by 3. In other words, we need 1/3 times 6/7. And this is equal to what? 2/7. Because we have 6 1/7, we divide those 6 into 3 equal groups, and so each group will be 2/7. And so therefore, 2/3 times 6/7, remember that's 2 times what you get when you do 1/3 times 6/7, because this was, we divided 6/7 by 3, and now we need to multiply this by 2. And so that's 2 times 2/7, and that's 4/7. We divided 6/7 by 3 to get this, and then we multiply that by 2. And we get 4/7. So for instance, let's do another example. Let's say that you had 5/6 times 7/4. Again, we need to divide 7/4 into 6 equal pieces, but that can't be done evenly, so we rewrite 7/4 as 7 times 6 over 4 times 6. We split up the 1/4 into 24ths, and we will get 42 over 24. So this is 5/6 times 42 over 24. And now to do that, first, just forget the 5, right? Pretend it's a 1. We have 1/6 times 42 24ths, and this is 7 24ths, because 42 divided by 6 is 7. And now the next thing we do is we multiply the result by 5. And that gives us 35 24ths. Because again, we want to think of 7 over 24 as 7 of something. It's, you take 7 units of length 1 over 24, and when you multiply that by 5, you get 35 1/24ths, which is 35 over 24. Okay, 35 24ths. And in general, what we discovered is that if you take a fraction a over b, so this would be like 7/4 in the previous example, and do m over n times it, this is going to be, okay, so what is that? So first, this is a good summary of what we've done. first rewrite a over b as a times n over b times n. That way the numerator is a multiple of n. Then we do 1 over n times that. So 1 over n times a over b is 1 over n times a times n over b times n. So this is a times n number. This is a times n 1 over b times nth, right? And you divide that into n equal pieces. This is going to be a over b times n. A b times nth. And now finally, so this is 1 over n, 1 nth times a over b. And then finally, m nth times a over b is just m times 1 over n times a over b. And this is, since we just figured out that this is a over b times n, this is going to be m times a over b times n. So we just discovered that, and this is a times m over b times n. So we discovered that this is equal, and I can write this as m times a all over n times b. We just discovered that you can multiply the numerators together and multiply the denominators together. So that's multiplying the denominators together, that's multiplying the numerators together to get the result. And in fact, a lot of videos will just explain that's what you do to get the result. But so why did we go through all this trouble of explaining all of this? Because you want to understand what you're doing, right? You want to understand that when you have m over n times a over b, what does this even mean? It means that you take a unit 1 length, you split it into b pieces of equal length, so that's 1 over b. Okay, you take a of those, and the length of those a pieces is a over b. Then what the m and the n mean is you take this length a over b, you divide that into n pieces of equal length. And then you take m of those pieces and put them together and see how much you get. That's what this multiplication of fractions means. And then we figured out that it's equal to this by the reasoning that we did. And the key step was this fact that you can rewrite a fraction in multiple ways so that the numerator was a multiple of n. Okay, I hope this video helped you understand why multiplication of fractions works the way it does. And that's really what I'm trying to explain in this video. Not just, see, if I wanted to, I could have just said, you multiply the top and multiply the bottom. But I didn't. And the reason is because, I want to, if you explain that, it won't make any sense. Like, why do you multiply the top and why do you multiply the bottom? And most people just won't explain it. They'll just say that's what you do. But I wanted to explain how this fits in with, multiplication, right? This 2 times 3 is 6 means you take 3 and then add 3. You take length 3 and then add another length 3. And how that fits in with fractions. Okay, I hope you found this helpful.